You have been visiting a distant planet. Your measurements have determined that the planet's mass is twice that of the Earth, but the free-fall acceleration at the surface of the planet is only 1/4 of that at the surface of the Earth. A. What is the planet's radius? B. To get back to Earth, you need to escape the planet. What minimum speed does your rocket need? In order to find the radius of the planet, we need the equation which states that the gravity of the planet is equal to the gravitational constant, g, multiplied by its mass, divided by the radius squared. We know this because of Newton's universal law of gravitation. We can solve for the radius of the planet by relating the equation for Earth's gravity to the gravity of the planet.
We know that the gravity of the Earth is equal to big G times the mass of the Earth over the radius of the Earth squared. We also know that the gravity of the planet is equal to big G times the mass of the planet over the radius of the planet squared. And because we know that the gravity of the planet is equal to 1/4 times the gravity of the Earth, we can say that 1/4 times the gravity of the Earth is equal to big G times the mass of the planet over the radius of the planet squared. Because we know that the mass of the planet is equal to 2 times the mass of the Earth, we can plug in 2 times the mass of the Earth into the mass of the planet in the previous equation. This leads us to 1/4 the gravity of the Earth is equal to big G times 2 times the mass of the Earth over the radius of the planet squared. Multiplying by 4, we get that the gravity of the Earth is equal to 8 big G times the mass of the Earth all over the radius of the planet squared. Because we know that the gravity of the Earth is also equal to big G times the mass of the Earth over the radius of the Earth squared, we can set that equal to the 8 big G mass of the Earth over radius of the planet squared. Now that we have those equal to each other, we can cross out the big G and the mass of the Earth, leading us to have 8 over the radius of the planet squared is equal to 1 over the radius of the Earth squared. Once we cross multiply and square root both sides, we get that the radius of the planet is equal to the square root of 8 times the radius of the Earth. And because we know that the radius of the Earth is 6.371 times 10 to the 6 meters, we can multiply that by rad 8, and we get that the radius of the planet is equal to 1.8 times 10 to the 7th meters.
To find the velocity of rocket, we will use the formula energy of the rocket equals gravitational constant times mass of planet times mass of rocket over the radius of Earth. Now the mass of the rocket will cancel out, and we solve for the velocity of the rocket. V equals square root of 2 times big G times mass of planet over the radius of Earth. We can substitute mass of the planet in for 2 times mass of Earth, and we know that the mass of the Earth is 5.972 times 10 to the power 24 kilograms. After plugging everything in, the velocity of the rocket comes out to be 9411.23 meters per second.